All right. Good evening, everybody. So, in today's experiment, we are going to calculate the unknown concentration of proteins by using stimulated electrophoresis of protein on polyacrylamide gel with SDS. So, before we start on with the project or assignment, we need to read the instructions given to us. After reading them, we have to do the same. So I've already read the instructions and I'm going to do the experiment. So this is a console panel. So for the for doing our experiment. So before I start off with the project or assignment, I'm going to tell you in brief. So basically, as you can see here, this is unknown concentration of proteins, and basically it varies from unknown concentration 1 to unknown concentration 10. Then we have acrylamide percentage that varies from 7.5 to 15%. And then we have standards as shown here. And in standards, we have beta gal, oval B, carb anhydrous, TIM, known as TIM, myoglobin, lysosome, and BPTI. So here we can see these are the voltages, and as the instruction already mentioned how to use this console, so I'll show you how to do the experiment. So let's start with the experiment. Now for the first sorry so what we have to do is we have to calculate the molecular weight, sorry, not weight, I mean molecular mass for these 10 unknown proteins. uh, and we have to set the concentration of acrylamide accordingly, and we have to select each and every standards here. So just click on each and every standard here and take voltage. uh, I have taken voltage as 100 volts. It doesn't matter if you take voltage as 50 or 150 or 200, but there will be a slight difference in the speed of the bands. So I have actually taken 100 volts here. So I'll be starting off with the acrylamide concentration. So firstly I'll be taking 7.5. So it has already been set to 7.5. Now what I'm going to do is I'm going to click here on add standard. Now here the standard is added, and then the sample is added. After doing that, there are two buttons here, as you can see. One is the start button and one is the stop button. So I'm going to click on the start button. Okay, yeah. So after starting it, when the bands will reach the end line of the acrylamide, I'll stop it. So I have stopped it. Now after doing so, I'm going to click on this black band. So this black band is nothing but it actually identifies the protein concentration or so. As you can see here, we have relative modivity, that is 0.16. We have to plot this result in the in the graph. So here it is taken as 0.16. So we have to calculate it for 0.16. So I'll plot it here. So I'll click on 0.16 and we got the value. So before I tell you about this, let us know about this thing. The x-axis here, as you can see, shows us the relative migration basically. So my bad, this part, as you can see here, is the relative migration, that is 0.16. And this part that you can say y-axis is our molecular molecular weight. So as I plotted for 0.16, it actually got corresponded, and our value came out to be our actual molecular weight came out So I will click on protein information, and this unknown protein one is basically aconitase, or you can say acon for its abbreviation, and its molecular mass is 82512, as you can see here. So this basically is the experimental value, and this, as you can see here, is the value that we have calculated. So as you can see, the calculated value is basically bigger than the experimental value. So this was for acrylamide concentration 7.5. All right, now we will check for others as well. So I'm going to go to set parameters once again, and then stimulation. After doing this, I will go to 10%, and then I'll do add standard, add sam add sample, and then I'll click on start. After doing so, when my band reaches the end limit, I'll stop it right there, and then I'll click on this black band. After doing so, we will plot the result. After plotting it, it corresponds to molecular weight, and we got a molecular weight, and there is a difference in the molecular weight. As you can see, the actual molecular weight does not even is not even close to experimental one. So just let's just forget about it, because it's not even close to this. So what we are gonna do is we're gonna do for sorry okay, so what we are gonna do now, we are gonna do for unknown concentration 2. After doing for unknown concentration 2, I'm going to click here on add standard. Then I'm going to click here on add sample. After doing so, I click here on start. As my bands have reached the end limit, so I just stopped it. And now I'll click on this black band and I'll plot the result. So I'm getting my result as 0.53. So here is my 0.53, and it will get corresponded. And as you can see, is the value the actual molecular weight, or the value, is coming out to be more than the experimental value. Now I'll just click here, because this is the unknown 2 protein, so we wanted to know about this protein. So this protein is actually known as concanavalin A, or con A, and its molecular mass is 2556, as you can see. All right, this molecular mass is calculated by us by using by using this graph, and it's not even close to this. It is actually greater than this. So now we will go to stimulation, and then we'll set parameters. We'll go to 7.5, then we'll go to add standards, then we're going to add sample, then we're going to start. And as usual, when the band reaches the end point, I'll just stop it. So I just stopped it as the bands reach the end point. I'll go to stimulation. Sorry for the inconvenience caused. All right, now we will continue with the same. So I have written the molecular weight for unknown concentration one, that is 82521. All right, after doing so, we will calculate it for unknown protein 2, and I'll set this to 7.5 itself. After doing so, I'll add standard as usual, and then I'll add sample. I'll click to start, and after that, when the bands will reach the end point, I will stop it. So I stopped it, and now I'm getting the value as 0.53. So as you can see here, I got it as 0.5, sorry, 3. Oh shit. Okay, so here it is coming out to be 0.53. So it corresponds and gives the value something. Okay, so as you can see, the value is coming out to be correct. So if we click on protein concentration, the unknown protein 2 is identified as concanavalin A, and its abbreviation stands for con A. So as you can see, the molecular mass is 2,556. So I'll just write it down. So I will just enlarge this for my convenience. um, Unknown. Alright, and for unknown 2, molecular weight for unknown 2, it is equals to, just a sec. Alright, so for unknown 2, it is coming out to be 2,556. 2,556. Alright, so after doing so, we will go to parameters, and then we will click on unknown concentration 3, and obviously the concentration of acrylamide will be the same as 7.5. Then we will go to stimulator, and then we will add standard, we will add sample, then we will click on the start button. And as usual, when the when the bands will reach the end point, I'll stop it. So I stopped it, and I am getting my relative migration to be 0.25. So it is coming out to be 0.25. I'll plot this, and it actually corresponds and gives a value around 61. So this value, as you can see here, the actual value and the experimental value, there's a lot of difference. So we cannot just consider this value. Um, because this value is actually greater than the experimental one. So we're going to go on parameters, and we will set the concentration of acrylamide to 10%. After that, we are going to add add standard, then we are going to add sample, and then we will start. And the band is actually reaching near the endpoint, so I will stop. After stopping it, my value is coming out to be 0.12. Relative migration is 0.12. After doing so, I am getting my corresponding value. So the corresponding value is, so basically, as you can see here, the actual value is basically much lesser than the experimental one. So we are not going to consider this because it's very less, as you can see. So I am once again going to parameters. I'm going to change the acrylamide concentration, and then I'll add standard, then I'll add sample, then I'll start. After starting, when the bands will reach the end, I'll stop it. After stopping it, I'll click on this, and the relative migration is coming out to be 0.08. And yes, my values again, my actual value is greater than experimental. I cannot take this, so I'll just click for 15% concentration of acrylamide, then I'll add standard, then I'll add sample. After doing so, I'll start off, and then I'll stop. After stopping, just click on this and go to plot results. The relative migration is 0.04, and it does not match. So we have to go to 7.5% of acrylamide once again. After doing so, just start. After starting, just stop when it reaches near and plot the result. So 0.24 is coming out to be relative migration. After doing so, as you can see, our actual value is basically, you can say, much more closer to experimental value, so therefore we can take this value. So we can write 63058. 63058. All right, here it will come as 63058. Let's just confirm. So it's 64, sorry, it's 63058. All right, so this is molecular weight for unknown protein 3. All right, all right, we got it for protein 3, and now I will do it for protein 4. So I will go to 4 and I'll click on 7.5 itself, and then I'll add standard, and then I'll add sample, then I'll click on start, then I'll stop, then I'll click on this, and I get my result, relative migration as 0.36. After doing so, I'm getting the corresponding value as, okay, so I'm getting my value as 43505. So unknown 4 is equals to, sorry, it is coming out to be 43505. All right, then again go to parameters and change, set it to unknown 5, then add standard as usual, and then add sample. After doing so, click on start. After clicking on start, just click stop when the band reaches the end of the terminal. After doing so, I'm getting my relative migration as 0.12, and after plotting this, I'm getting the value. So this value is 94,000. So this value is totally accurate and it actually matches. So this unknown concentration, my fault, this unknown protein is phos B. So its molecular mass is coming out to be 94969. 94969. All right, so we will calculate it for 6 as well. So after doing for this, we will calculate for 6, we will add standard, we will add sample, we will do start. All right, so after doing this, the band reaches the end and we got our relative migration. So it is coming out to be 0.28. So 0.28, we plotted this value and our corresponding value is coming out to be, so as you can see, the actual value is greater than experimental, so we cannot take this value. So we will take 10%, and then we will try to do this. Then we are going to add sample, then we are going to do start. Then we will stop, we will click on this, and then we will get our relative migration as 0.14. And after doing so, we get it as 70. So this is not correct, so we need to change the concentration percentage of acrylamide to 12. Then we will add sample, then we will start. After doing so, just stop. When the band reaches the terminal, click on the black band, and the relative migration is coming out to be 0.09. So as you can see, this value is comparatively close to this value. So this unknown protein 6 is pyruvate kinase, or PK. So molecular mass is 56773. So it's 56773. All right. So for the molecular weight for sixth one is done. The molecular weight for unknown protein 7 is, so I will go to set parameters, and then I'll go to unknown 7. After doing so, I'll go to 7.5. So we will add standard, then we will add sample, then we will start off with the experiment. And once the band once the band actually reaches, sorry, my fault. So when the band actually reaches the end terminal or the last line, then we need to stop. So after doing so, just stop when the band is actually approaching the end line or the end terminal. After doing this, we got our value as 0.73. All right, 0.73 it is. And all right, so as you can see here, the protein information, this is ribonuclease A protein name, and its molecular mass, or you can say molecular weight, is 13637. 13637 673, sorry, my bad, 673. All right. um all right, so these two values are basically relating to each other, and they are 13,000, so it's very close to each other. So this value can be taken ahead. And now I'll go to set parameters, and then I'll take out the concentration of 8, unknown protein 8. After doing so, I'll add standard first, then I'm going to add sample, and then I'm going to start. And after starting, I will stop this experiment. Sorry for that, I was not able to click on time. So then add sample, then we will start off. After doing so, we will stop when the band will be reaching the end terminal. So we stopped. After this, we will plot the relative migration to be 0.56. All right. After doing so, we get a corresponding value of 23. So this is unknown protein unknown protein concentration 8, and it is actually chymotrypsinogen. So for this one, I'll write molecular weight for unknown protein 8, that is equals to 23564. 23564. All right, now I will write the unknown concentration for 9 and molecular weight for unknown 10 would be. So I will calculate it for 9. So I'll set the parameters and then I will click on 9. All right, clicking on 9, I'll add standard, then sample, then start. After starting, we need to stop when the band reaches the end terminal. So after I stopped it, I will see what is the relative migration. It is 0.36. So it is 0.36. So after plotting this graph, we get the corresponding value as 43, and it's pretty suitable. Okay, so you can see the unknown protein here is p-hydroxybenzoate, and its molecular mass is coming out to be 43939. So it's 43939. All right, what about 10? All right, so for 10 we will calculate. So for unknown protein concentration 10, we will add concentration, we will add standard, then add sample, and then we will start. After starting, we will stop the bands while they are reaching the end terminal. So I stopped it and I click on this, and then I will get the relative migration to be 0.67. All right, got it. After doing so, we get the corresponding value as 16. So this protein information is written here, and it is actually known as ribonuclease H, and its molecular mass is 16638. So it's 16638. All right, so I have written the molecular weight for all the unknown unknown masses, that is from unknown proteins, that is from unknown 1 to unknown 10. After doing so, this came out to be our molecular weight for unknown concentration, and that was it for this video. Now in this combined video itself, I will show you what to do and what are the practice questions and how can we solve them. So for that, please stay tuned. All right, so now okay, so in video this video is about the practice. This video is basically the practice video. Oh, sorry, I don't know what's, oh shit. All right, sorry for the inconvenience. So what I was saying is, this video is basically the practice video. So these are some questions given to us, and we have to calculate it, and or we have to mark the correct answers. So the first question for the practice exercise is influence of the applied voltage. Okay, all right, so it says load the gel with all the standards and any one of them, one of the unknown protein samples. Okay, which is okay, so choose in turn each of the voltages available in this simulator and run the electrophoresis until the tracking dye band, that is purple color, approaches the lower end of the gel. Write down in each case the mobility um of the standards. All right, so what we have to do is, in simple or in short language, I'll just tell you. We have to basically we have to calculate influence of applied voltage on um, influence of applied voltage on these standards. So what we have to do is we have to select different voltage from 50 to 200, and we have to see whether this voltage is affecting the standard and how it is affecting. We have to see that. So for basically for calculating this, I am setting my voltage at 50 volt, and I'm taking the unknown concentration as 10 only and acrylamide concentration as 7.5. I'll add standard. Okay, then I'll add sample. Then I'll start. And all right, as you can see, the purple the track purple dye reaches the end, and I click on this black band, and I'm getting the mobility as 0.67. So I have to write down the mobility of each and every you know for each and every voltage. So for 50 volt it is coming out to be 0.67. Let's see it for 100 volts. So we have to do the same thing. We will add the standard, then we will add the sample, then we will start it, and the track die band is actually reaching the end. So oh shit, there is some problem with my mouse. I'm so sorry for that. I'll just do it once again. So we will add the standard, then we will add the sample. uh, After adding it, we will start it. So after starting it, we will stop it, and we will click on this, and we are getting our mobility as 0.67 in 100 volt as well. All right, now we will click on 150 volts. We will add standard. Okay, all right, then we will add sample. All right, now after adding sample, we will start it, and the purple tracker die is coming to the end terminal, so we will stop it. After stopping it, I'll click on this, and as you can see, we are getting our mobility as 0.67 in this case as well. And this is the last case. Add sample, then start. Alright, so I'll just stop here. Okay, so as you can see, we are getting 0.67 as a mobility. So as you saw in this case, or in this experiment, or you can say in this question, that that asked us to determine the influence of the applied voltage. So as you can see, um, uh, in 50 volts, in 100, and so on till 200 volts, the mobility was the same, that is 0.67. But there was one thing that was different, was the speed of the standards. So as you could see, the speed of the standard varied differently from 50 to 200 volts. So 50 volt has the least speed in term of the standard, and 200 volt had maximum speed of standard, as you could see. So if I were to choose from all these options, my question asks me, which is the effect of an increase in the voltage applied between both the electrodes? So my answer would be that my standards are actually moving faster. So I will click on this option, and I will check, and it actually says that my answer is correct. All right, now I will now in this case, it is asking me to determine the influence of the acrylamide concentration. So what I have to do is, I have to change the acrylamide concentration, and it basically varies from 7.5% to 15%. So what I'll do is, I will set my voltage at 100 volts, as I did in video 1, and I will just change my acrylamide concentration. So for the timing, I will take 7.5%. So I'll just add standard. All right, then I'll add sample, then I'll add start. And after running this, the purple band is reaching the end terminal. So before it reaches, I'll stop it. I'll click on this black band, and as you can see, my mobility is 0.67. It actually says us to write down in each case the mobility of the standards. So the mobility came out to be 0.67. All right. Now I will take 10% acrylamide concentration and I'll add standard. Then I'll add sample and I'll start. The purple band is actually reaching the end terminal, so I'll stop here and then I'll click on this. You can see the mobility is still 0.67. All right. Now I'll just click on 12% and I'll add standard. Okay, then I'll add sample. After adding the sample, I'll start it once again. And then as the purple dye is reaching the end terminal, I'll just stop it. So here I stop. And once again, I look at it. You can see the mobility is coming out to be 0.67. All right. Now I will, change the concentration of acrylamide once again. So it will be 15% this time. And then I'll add standard. Then I'll add sample. Then I'll start. After starting it, the purple dye reaches the end terminal, so I'll stop it. After stopping it, I'll click on this black band, and as usual we're getting mobility as 0.6. So the mobility is still the same, so but we can see that uh, during this case or experiment, we could see that the increase in concentration of acrylamide actually led to decrease in the speed of the bands. So as you can see, and now therefore we can actually conclude that acrylamide concentration of acrylamide is directly proportional to the speed of the standard, sorry, or the bands. Okay, so if the increase in acrylamide's concentration is there, then the speed of the band will be slow. So if I am asked to choose the correct option from these, then I will choose the standard move slower. I will check the all right, so I just checked the answer and it was correct. So all right, and now it says that sorry, yeah, so in the next question it is actually asking me that how can you interpret this result in terms of the mechanism of separation. So according to me, out of these four options, I think, um just a second, I think this option is correct, so let's check the answer. All right, sorry, my fault. um all right, sorry, I wanted to click this one. So yes, a higher acrylamide concentration basically produces a gel with smaller pores, so protein actually move more slowly. So this was because I just told the explanation right now. I just explained it and it was based on that, so this answer is correct. After that, self-assessment of results from molecular mass. So yeah, I just entered one molecular mass, the first one, and it was correct, and I'll fill in the rest of the details. So as you can see, this one is for the second, so I'll just copy it and I'll just paste it. So I'll just paste it here. After pasting it, I'll just check and the answer is correct. For the third one, I'll copy. Yes, the answer is correct. Now for the fourth one, yes, I'll copy this. All right, for the fourth one, the answer is correct actually. For the fifth one, copy. I'll paste it and I'll just check. The answer is correct. For the sixth one, where is the sixth one? All right, as you can see, this is the sixth one. I'll just copy this. Sixth one, right? Yes. So this is for the sixth one, and the answer is correct. For the seventh, I'll just copy it. Shit. Oh, sorry. Uh, okay. All right. Is it? Yeah, yeah. All right. Just let me check. Yes, it is correct. Um. All right. Now I'll just copy for the eighth one, and I'll just paste it. Or oh. All right. It is correct. And for the sorry. For the ninth one, I'll copy this. Copy. Sorry, paste. Yes, it is correct. And for the last and the final one, I'll copy it. Alright, and then I will paste it here. And the answer is correct, as you can see. So the molecular mass that I calculated was correct, and I have actually showed it in just a few minutes ago. So this is correct. So now, just a second. So I don't need this Word document anymore. Alright. Sorry for the inconvenience. I'll just. Alright, now we come to this section or this part wherein we have to, determine, we have this thing, determination of quaternary structure. So, so here, what we have to do is we have to first, read the question. So it says run the electrophoresis until the band of the tracking dye, that is purple color, approaches the lower end of the gel. Okay, alright. Load the gel in stimulator with all the standards and any one of the unknown protein samples. Load the gel in the stimulator, alright. Load the gel in the stimulator, okay. With all the standards, alright. And any one of the unknown protein samples. Okay. Although you will not use the latter, no problem. Alright, so I'll just add standard. Then I'll add sample. Alright. Okay, after that, what I have to do is I have to do start. So I'll just stop it as it has reached the end terminal. Now I'll just click on it and I'll plot result. So it says, so it actually says an enzyme is treated with SDS and beta merca ethanol and analyzed on a polyacrylamide gel with SDS. Two bands are observed with relative mobilities of 0. Alright, so I have to plot for 0.47, and then the next one I have to plot is for 0.59. So if I plot for 0.47, here it comes, just a second. It comes 0.44847. Alright. So my value is alright. So my value is actually coming out to be, just a second. Alright. So this one is actually the smaller subunit, no? So I'll just write 20572. All right, just let me check. All right, the answer is not correct. Let me. Answer is still not correct. Okay, no problem. I will just 2572. Let me check. The answer is still not correct. All right. All right. The answer is still not correct. No problem. I'll just do it once more. So, thanks to some independent experiments involving. All right. So, okay. So it has said that I have to do it for 0.59. All right. 0.59 will be here. Sorry, 0.59. Let's see. All right, so for 0.59 I'm getting somewhere around 16. Okay, it's 16 241 214. Sorry, check, it's wrong. All right, cut. I'll just copy it here. Let's see if it's correct. No, it's still not correct. All right, no problem. I'll just do it once more. So, all right, so no worries. All right, so I was having some issues earlier, but I was not able to get my answer correct. So I will read out the question once more. So it basically told us to determine the quaternary structure. So here it has given us an enzyme that is treated with SDS uh, and so on. And we actually observed that the two bands are observed with relative mobilities of 0.47 and 0.59. So I did it once again. So this time I kept my acrylamide concentration to 7.5, and then after doing so I added standard, then I added sample, then I clicked on start. After starting it, when the purple track die was actually reaching the end terminal, and I stopped it. After stopping it, I clicked on this and I'm getting the mobility as 0.67. So after this I had to plot for 0.47 and 0.59. Here what I feel is 0.47. As you can see here, 0.47 will be the largest subunit, and 0.59 on the other hand will be the smaller subunit. Let's see. So 0.47, that is 47. Yes, all right. 0.47, we are getting the value for the largest subunit as 30 uh 884. All right, let's check. The answer is not correct, so I don't know what's wrong, but I just tried it with 30,000 and it was actually correct. So all right, no problem. Now I have to calculate it for 0.59. So I will plot for 0.59. So 0.59, sorry, for 0.59 it will come out to be as, all right, so you can see the value for 0.59 is 21,594 549, sorry, check. Okay, so as you can see the answer is correct. All right, so now it says the quaternary structure, so we have to choose which of the quaternary structure it is. So from my side it is A3B2. Let's check it out. and the answer is correct. So these were all the questions for today's practice lab from the practice exercises, and that was also, thank you so much for joining me. And yeah, thank you.